Okay, welcome participants. Welcome back to the CMO UT Teacher e-training series. Today is course 1, Computational Thinking, How to Develop at Primary School, Lesson 2, Computational Thinking and Examples. We're so happy to have you back.
Okay, welcome participants.
Sorry.
Welcome back to the
My
UT.
setting was wrong. Yes, welcome back. We're so happy to see you again in our lesson. I hope I am audible. Okay, so before we start our lesson today, I would like to start with some announcements. Let me share you the slide. Okay, so I hope my slide is visible. I am showing the information about our textbook. The textbook for this course is now available on our website. So we would like you to download through this QR code to be ready to participate in the rest of the course. And actually, in today's assignment, you will need to download one of these textbooks. So please be sure to download it. Okay. And the next thing is about our cycle of the lesson. Actually, I got some inquiries from the participants that I haven't received the link yet, or where can I submit the assignment, those basic things. So I would like to briefly review our platform. So today is Wednesday, and the live stream for this year will be done on Wednesdays. But due to various reasons, those who cannot attend on the live stream, you will have 4 additional days to work with the assignment. And the due date of the assignment will be on Sunday. So please take your convenient time to work on with your video and submit the assignment. And once you submit the assignment, you will receive the next lessons link by next Tuesday. So I hope you can get used to our new platform. So for this week, today is the 10th. So the homework will be submitted by 14th Sunday. And we will give you the link by the next lesson. And there are some cases that you cannot receive the message with a link included. So please, once again, check your settings of your email to receive our link successfully. And if you have any inquiries, please don't hesitate to contact us. Thank you very much. So we would like to move on to today's lesson.
So here is the structure of course number 1, lesson 2. We would like to start with the answers to the questions raised from the participants in lesson 1 by Dr. Masami Isoda, University of Tsukuba, followed by the keynote lecture on computational thinking by Dr. Roberto Araya, University of Chile. After that, we would go through the examples from the guidebook on chapter 1 by Dr. Narumon Changsri from Konkan University. Then the commentary on the guidebook by Dr. Raimundo Olfos and Soledad Estrella from Pontificia Catholic University of Valparaiso. Finally, the theme will move on to the computational thinking with computer, presented by Dr. Wayudi Simio Simolek and Dr. Warapon Peterpon from Simio Wrexham. So let's start with the answers to the questions raised by the participants in lesson 1.
Sorry. This is the QA session.
Hello everyone. Thank you very much for your attendance of the computational thinking course. This is the question and answer sessions for lesson 1. Thank you very much for providing us the several questions. Many of the questions are related with later lessons. So today, I just answered 2 questions. First question is from Dr. Buemia from Philippines. If we are to embed this in our existing curriculum, is there need to increase the time allotment of the required lesson in our current curriculum? What integration approach can you suggest? Thank you very much, Dr. Buemia. Yes, the question accepted to use the guidebook in the classroom. Yeah, it is happy. And asking how. The current curriculum content is done in the given schedule and where we shall find the opportunity for implementation. That is the first part of the questions. And the suggested idea is the following. It is up to whom you are. Okay? Firstly, for curriculum developers who have responsibility to develop national, district, or school curriculum, it might be the opportunity to implement lesson study as for curriculum reform. Based on several exemplars, the reform can be proposed. Yes. Then, curriculum developers enroll to ask teachers to engage in lesson study, right? That is the first case. And secondly, for the teachers, okay? For teachers who propose innovation in education through lesson study. Yes, you are the leader who shows the class to the others. The guidebook provides you the ideas for teaching approach as well as the exemplar for the classroom use. Do you remember this task? Okay, we discussed. Okay. You can produce your own worksheet like the coloring book, which embedded your necessary content of teaching under the given curriculum. Okay? You can develop these types of worksheet for your content. Then it's promoted to develop computational thinking and so on. Okay? I will remember the experience to go to the Honduras, and for coming back, I go to the Honduras with the teachers, the Kozo Tsubota. On the travel between Honduras and Japan, he just wrote a book. Between Los Angeles and Tokyo, it takes 13 hours. During 13 hours, he has a notebook and begin to write from the worksheet for the publication. And he finished it, one notebook, during his travel. Okay? Such a super teachers engaging in the lesson study and propose the ideas for teaching. Okay? You will be the super teachers. And if you wanna see his activity, please visit those URL, those QR code. You can see who is the Tsubota sensei. Okay? So thank you very much. This is the answers. Okay? You can produce your own worksheet inspired by this guidebook. And then you can implement current curriculum. That is the answer. Okay? And this next question is done by the Dr. Petri Nurani from Indonesia, UPI. His question is, are there any specific indicator for computational thinking skills at elementary school level? Okay. And whether the same indicator can be developed in coloring activity or math or STEM lessons. Thank you very much, Dr. Nurani. Yes, the indicator is necessary in education for the assessment and so on. However, it is not easy to provide understandable answers for primary level teachers. Exceptionally, the case of mathematical thinking, because informatics and STEM are not existed as a subject of teaching in their curriculum. Okay? There are no name of the subject informatics and STEM currently. Okay? So that is the challenges of the guidebook. Thank you very much. And in the case of mathematical thinking, yes, primary school level teachers teach mathematics. Yes, there is a subject of teaching. So they already know mathematics at primary school level, right? And my answer is, if student can answer teacher's question in mathematics class, such as, what do you want to do next? Teacher asks student, what do you want to do next? Okay? Or they begin to explain their ideas by using the word, for example. For example means something new, right? And or begin to critique others. If you are saying true, what will happen? This kind of questions or answered by themselves, it already indicates that they are thinking mathematically by and for themselves. Now, Indonesia use Indonesian adapted edition of Japanese mathematics textbook, originally published from Gakko Tosho, which is written by our affiliate school teachers, primary school teachers. And it is developed by the super teachers who, okay, and they pose, their classroom student pose such a questions from the first grade of the primary school level. Okay. Then it might be the opportunity to develop student by using the textbook in the case of Indonesia. Okay. This one is the Indonesian edition and this one is the Chilean edition. Okay. Then so in such a country, it might be the good opportunity to develop students by using the textbook. And since the year 2020, Japanese original edition, the Gakko Tosho mathematics textbook have 2 pages in every grade to develop computational thinking. In mathematics textbook, there is a pages to develop computational thinking. Such ideas are embedded in this guidebook, in the chapter 2 mathematics. Okay? Mathematical activities in chapter 2 in the guidebook. And in the case of coloring book, chapter 1 of the guidebook, editors, we asked the original author, is also the editor, Dr. Roberto Araya, to write the indicators, and he wrote it by using programming language based on his specialty on AI and informatics. Dr. Roberto Araya is a specialist on AI and informatics. He wrote the textbook for the university level from the edition with him. Okay? However, it might be not understandable for primary school teachers because primary school teachers are not the specialist for the informatics. Then we did not indicate it in the guidebook, even if it is well written, well done. Then it implicates that the terminology which is useful to explain the objective and the indicators at primary school level should be clarified as soon as possible. Yes. Let's collaborate to develop the terminology which provides the appropriate indicators. It is an opportunity for international collaborations, collaborative research, as for next step of the guidebook. Let's do and develop the indicators by ourselves with collaboration. Thank you very much. Those are the answers for the questions for the first lessons on the computational thinking course. Thank you. We are looking forward to your further questions for the next lessons. Thank you very much.
Okay, thank you very much. That was the questions from the participants from lesson 1. We also have a chance for you to ask some questions. Okay.
Next is the keynote lecture on computational thinking by Dr. Roberto Araya, University of Chile.
For the first keynote speaker, I would like to welcome Dr. Roberto Araya, a full professor from University of Chile. His topic is on computational thinking. Professor Araya, the floor is yours, please.
I want to thank Professor Zora, Professor Impasita for all these years. We have learned so much from you and from all the other participants of the other economy. So thank you very much. Okay, so now I cannot move this thing. Why does it? Oh, here. I'm going to talk about computational thinking, then something about programming languages, cognition, textbooks, and finally the coloring tasks. Computational thinking. So what is computational thinking? How is it different from mathematical thinking? Professor Isori is expert on this. So many years also we have been working in mathematical thinking. I think the key idea is we somehow need to compute. That means put everything in elementary actions that a machine can execute. So that's the final aim. And it has some mathematical reasoning. For example, these are just now the new language system that they're able to read a problem and solve it. Like here, like this equation has two complex solutions, determine the value of the real person. All this, the machine itself. So that's now it's a question: what should we teach? Because the machine is doing this, and this is a performance all these years of in math work problem the machines is already doing. We have been working with Professor Isoda, Professor Gonzalez, and Professor Implicita on a framework for computational thinking. And here is, in APIC, we developed the framework, basically has algorithmic thinking, these logical quantifiers, then has these computational models, how to model the reality using the computer. Like, for example, we have done first-field propagation, pandemic propagation, and then machine learning thinking. So this is connected with statistics and linear equation, linear network. So that's mainly the three components of computational thinking. Now, how different is this from programming language? So we have, in 1942, Ada Lovelace, the first programmer, invented a first code to compute. Then in digital computers in 1947, we have the first assembly languages, very basic, low-level kind of languages. You have to specify everything, just has to add ones plus zeros. Everything is very high, low level. But then it started more higher level languages, and it's more easy for human languages like Fortran, Lisp, and now Python, 1990. Then visual programming languages like Macromedia, Authorware, Adobe, and GameMaker. I used to use GameMaker to make games and Scratch. Now with AI and automatic code generation, so now what is going on? Because now the machine is able to understand our natural language and produce programs. So here is Ada Lovelace. And now you say to draw a star with a pen, and the machine will automatically produce the whole code, let's say in Scratch or in Python or whatever. So some people are saying that it's going to be the end of programming. We just don't need to program. This is the Huang, the CEO of NVIDIA, in the World Summit recently, said we will not need to program. But what do we need to think? And then this is also some artificial intelligence index on how the machine is doing in visual common reasoning, in mathematical reasoning, and it's improving. It's incredible. This is a human baseline, and it's improving several machines. And also for coding, this is a test, the difficult test for coding. But you write to the machine what you want to do, the machine will produce the code. The performance is improving so much that it's really incredible. And so let us think, what is computational thinking, and what should we understand? Finally, according to Geoffrey Hinton, he is the Turing Award in computer science. This is like a Nobel Prize in computer science. He claims that machines are starting not to do this thing, but it's starting to understand what it's doing. So it's really incredible. It seems that the machine is able to understand. Now, dual cognition. So we need, in computational thinking, mathematical thinking, you need to understand cognition, what it is. And we see the standard model now. There's one processing is automatic, autonomous, very fast. It's a Kahneman model. Nobel Prize just died a month ago. And processing is more conscious, and the conscious part has a more algorithmic mind and reflective mind. So somehow this is represented in this metaphor. The elephant is like the fast system, emotional system, very well adapted, but for all kind of problems in the history of human mind. But the conscious mind is always working with this and trying somehow to detect and inhibit certain behaviors, and the conscious mind needs to talk to himself like inner voice. So somehow this is the model, and then we'll see that we're trying to do. And the model means that initially you start talking with somebody else, with your mother or your brother, or in this case a hand puppet, and finally you internalize this inner voice, and you put yourself. That's basically reasoning. What kind of reasoning? And so somehow we have to promote this kind of behavior in how to reason. It's like talking to somebody else, but it's just yourself. So you need the traditions to have texts that helps in this and different tools. And you start with the Sumerian table, 2000 before Christ. You already have some teaching ideas in this kind of textbooks. And then even Khaldun, like in 1877, said, okay, students should first be taught calculations. He put a lot of emphasis on calculations and in sciences. And then we have the Treviso arithmetic, the art of the abaco in 1878, that cited several ideas from the Arab world. And it was supposed to be the first mathematical textbook. So this is where it started. And finally, we have the Comenius, maybe because it's like the first really textbook, the Comenius textbook, a revolutionary book, especially designed for kids. And, it's had several very interesting ideas, like what encyclopedism, bilingualism was in Latin, but in vernacular Italian or French, and then German and English. Also the visual imagery. So starting to use visual imagery to teach. So according to Comenius, there is nothing in our understanding that has not passed through senses. So the importance of sense. And that's very important because we were talking about coloring books, visual programming, so it's senses. So it's not just poor thinking, but it's connected with senses that somehow this is the pedagogy behind that we're trying to pursue in this work as well. But it has some limitations. It was very reading, not active actions. For example, coloring is active. You have to write. Also, you have to color. Also, you have to write explanation. It was just a passive thing. Supposed to be an isolated reader. We try to do more social learning with this the coloring book. So you pose a problem to a classmate. And a classmate, we have to do this. So it was more hierarchical teaching, and we tried to do more dialogic pedagogy in the coloring activities. So with this, now we can go to coloring that we did the guidebook in our work for years. So I'm very glad to also Masami and also to all my friends with Yudi, Sumartiono, Kichashai, and also been incredible work with Simeon. And I haven't mentioned everybody because I have not too much time, but I think was a great job. I learned a lot and, different views, how to now have a textbook that really use these ideas. All ideas were recombined in order to teach now computational thinking to kids. So these were my original books that have been translated. I'm very happy to Masami that pushed me to try to do these books initially a couple of years ago, and then try some initial lesson study with this book. These books has basically an A page and a B page. The A page, the student had to read it and read the instructions and then explain how to do this. In the B page is the more social thing that one student poses a problem for the classmate and he has to write the instructions and the other one. So it's not only doing things, but it's more active. You have to explain. Also, you have to pose a problem to a classmate. This is what we have done. Like in this one is in each box put at least 2 blue balls. It's what's called universal and existential quantifier. It's supposed to be more logical thinking, and somehow I learned this when I was in university, not even in high school. But it's put in this way, following this idea of Comenius of the senses, doing this visual representation, same as visual programming, then are able to connect the logic with these senses and solve very complex logical problems. There is, for example, like choose a color and in each box paint at least 2 balls of the color. And here you have in each box choose a color and paint at least 2 balls of the color. You think are these the same or are they different? Or in this one, in each box for at least 2 balls, choose a color to paint them. So each of these is a little bit different. Just somehow different what you have to do. And here is another one. Choose a color and in at least 2 boxes paint each ball of that color, and so on. So you see, are these different? And you can see in each box is in different places, and in each ball in different places. But then you have at least 2 balls, at least 2 balls, at least 2 balls, at least 2 boxes, at least 2 boxes, at least 2 boxes. So the question is, are these commutative? Are they different? So this is and to understand this, you need a deep thought. But if you do it with these boxes and with this ball, this task is not difficult for kids, and they like it, and they to think about this and then to paint according to these structures. So, and here we have another type of activity that I'm very happy. This is the first time I met Professor Isoda Masami was in Bandung. I was showing this activity. It was like 12 years ago. So you have a board. These are the numbered amount of food, for example, and then you have you have a small bacteria, and will move locally where is more food, and move to 10 or then 13, and then it will go to 21 and 22. This is a computational model of emotion, let's say, of bacteria. Of a computation, if you think of this number as the intensity of order, and you have a dog here, so it's the dog moving where it's more, outer intensity. And finally, when he gets to the maximum point, then it's like a bone is hidden there. So somehow can connect real problem with this kind of models. Very important. According to one of the fathers of genetic algorithm, boards are as important as numbers in mathematics and in computational thinking. But somehow boards are not taught in schools, only numbers. And here's the same activity, but then it's going to have to pose this problem to a classmate. So somehow this problem solving and explaining argument, you have to argument and reason with your inner voice. And here you have to pose a problem to a classmate, and he will do it. So you have the both sides. I think what I learned from posing a problem from Professor Imbrachita, that he had insisted in the importance of problem posing. And so we have the A and B is problem solving and argumentation, how you did it. And the part B is really posing a problem to your classmate, and he has then solved it and then have to make the reasoning. 2 days ago, I realized that I received an email saying, okay, there is a journal that has made US citation, but this journal was of, the Journal of Molecular Biology and Biochemistry. I thought it was something wrong with this. But why did they will tell me? I'm not working in this area. But then I realized, yes, they use in this for modeling this androgen receptor that has to be with testosterone, have 3 parts. I build a model of the CRISPR model of this. For doing this model, they use exactly what I've shown. So this is a rich elementary school mathematical learning with the steepest descent algorithm. That's what I show with the bacteria of the dog moving around. So, and what's interesting, that it seems to me that they found that this explanation in this paper was simple to understand. So these scientists in biochemistry and chemistry from a Belgian university, they explain the method to the other specialists. They use this example that we have done, and also it's been translated to Russian by Ivan. But he would later he asked me to translate exactly the same activity. So somehow was surprised that this computational thinking, this modeling, is not only interesting for kids to understand, but for all of us to get the main idea of this algorithm. Now, this algorithm is a very well-known algorithm. It is maybe have 100 years. I have thousands of papers about this, but somehow the core ideas are hidden and are difficult. And so if we're able to express for everybody, that makes a big difference. Now, this is a typical format of the coding book. You have a name, a problem pose, some picture you have to paint, and then you have to write explanation. And so we've been doing this, and then you have page A or page B. In page A, the system write we write the instruction. Page B, the student write instruction for a classmate. So that's the basic idea. And what we are doing now, we're trying to put in an app now, like to say, okay, welcome. to this. I would try to write in the other languages. I hope this is okay. And then once there, you can here use automatically one of these pages the students have been doing. And then when you do this, let's say you have this page that says from Robert Masami, in at least one box, in at least one yellow ball. And here's another instruction. So this is what I post to my classmate Masami. And then what will happen is that I get my smartphone, click here, and what it will use for me is, okay, it will translate what is been written here, and that's from Masami, write and paint, and then in at least one box, in at least one yellow ball, in each box, paint red at least 2 balls, and this system B will produce this. So now we have everything now in the server. We could not only on the paper, but we could have on computers, and we can then use big data to get all this information in maps for the schools and seeing how kids are doing and what kind of activities. So I see here a very interesting opportunity that is not only painting, coloring, and writing in paper in the books, but then this information will go to the clouds, to the servers, and we get a whole world of big data and trying to understand how kids are improving. So I see, and in this, AI is helping us to recognize the manuscript, to recognize where they paint, and connect and see the strengths and weakness of the student, and give some feedback to the teacher. So again, I want to thank Professor Masami and Professor Prashita for all these projects all these years. And now with this computational thing, we have to make a think. What is that we need to teach kids? What is the kind of mathematical reasoning they need? What is the kind of computational thinking they need? And what are the tools so they are be able to develop these skills connected with, in this case, with a little bit of art, and what I learned from Masami also with the aesthetic sense, and with the, as Comenius says, with the senses, the connection with the senses. So thank you very much.
Thank you.
Next, we'll move on to the examples from the guidebook on computational thinking by Dr. Narmon Chansri, Konkan University.
Let me share my slide, please.
Yes, please.
My presentation will focus on the guidebook for Unplugged Computational Thinking Chapter 1 using coloring book. There are comprised 15 tasks followed by tasks A and B. And today I will select some examples that Professor Araya mentioned in his presentation as a keynote session. The task is 10A. Could you please read the condition of task 10A? The first condition is paint the dress green. The second is in each box paint at least 2 blue balls. Could you imagine your student work? We have the suggestion for student learning process. The first, let's design a beautiful picture on your unique painting based on a given condition, then present into each other with an explanation. The second, let's explain your unique manner without showing the original picture itself to your friends, and the friends represent the picture based on your explanation, and compare your friend picture with your original picture. And we have some suggestions for student discussion. Through the comparison with others, let's think whose explanation is most understandable for you and appreciate whose on is very beautiful or unique for you? And how do you use the condition of at least in your painting? And I would like to share my experience in the classroom when I implement this concept to students. Here is student idea. The at least two blue ball concept were interpreted to only paint two balls in blue, like this. And students expressed excitement by the diverse outcome generated from the same set of conditions. They create an active discussion through this activity. And the next task is 10B. 10B is the open task which provides the opportunity for reflect on the 10A and utilize their learned how to. For the learning process for students, please let them set the new conditions for painting that produce beautiful pictures for you, and let's inform the authors. And what do you find after comparing your one with others' products? And for the discussion of students, how do you change the questions written on the picture on task 10A? If you learn from others, please refer whose idea you influenced and how your meaning of beautifulness has changed through this activity. And for the teacher, please let's explain the learning objective of this activity by using the following words, such as position, ordering, pattern, algorithm, and change condition. Could you imagine your student work based on their experience in 10A? I have some example. For this one, students change the condition. The first, paint the dress lace. In each box, paint at least 3 orange balls. This one, student pose question by changing the condition from green lace to pink and changing at least 2 blue balls to at least 3 blue balls. And this one, this group modified the condition to paint the balls in the order to of red, orange, yellow, and green. The order was distinguished by colors. Beautifulness comes from the ordering activity. And this is paint the dress pink, paint the ball in the box with orange and yellow. This group used what they learned in 10A. They recognize the 2 balls color, so they try to show 2 balls in red and the other in yellow with a design. They use color to design. This is a kind of STEM activity. And students found it challenging to color according to their peers' condition. The resulting work led to discussion about conditions, order, and position. Within the framework of C-based CCRLS in mathematics, this activity supports mathematical value, particularly in appreciating beauty. It promotes mathematical ideas such as pattern. And when you look at this picture, like 10A and 10B, what pattern do students find or use to paint the balls? Please. For me, in 10A, students learned about slope, and they then continue to use the idea of slope pattern in 10B. The slope pattern is beautiful, like this. Okay, finally, if you want to watch some example of classroom, please scan this QR code. You will see the full classroom with using this coloring activity. Thank you very much.
Now we would like to move on to the commentary on the guidebook by Dr. Raimundo Olfos and Dr. Soledad Estrella from Pontificia Catholic University of Valparaiso.
Hi, everyone. My name is Soledad Estrella from Chile. And
I am Raimundo Olfos from Chile too.
now we presented about guide book for unplugged computational thinking in online workshop for lesson study 2. Unplugged activities. This book allows to discover that prompts will empower students, allowing them to succeed in mathematics. The students improve their understanding and confidence in solving math problems. In this now new time, it's very necessary for boys and girls learn to create prompts from the first years of school. The guidebook analysis 3 types of activities. First, coloring activities to develop computational thinking, then mathematics and STEM activities to promote respectively mathematical and STEM thinking. This amazing white book was edited by Mr. Somsatham, Mr. Isoda, and Mr. Araya. The project aim is to provide primary teachers materials for contributing to develop computational thinking on artificial intelligence and big data era for digital society. In this interpretation, we will comment Chapter 1. Coloring activities encourage the development of computational thinking through natural language, which is foundational for using generative AI and reasoning for programming.
Yes, this chapter 1, is related to computational thinking. Okay, the chapter includes pair of tasks. Each task have 2 parts, 2 steps. At the left, we see the first one, the task A, and it provides sentence for indicate to the student what she has to paint. And the other side, task B, present the idea that a student provide her own sentence for invite to other students to find. Task B is an open task, which provide the opportunity to reflect on the whole previous activities. It is first approach to the construction of prompts. The task has a complexity in increasing and provide metacognition possibilities. At first, the tasks are simplest, piano red, and then increase complexity, top cat gray. Then in the other picture, we have skateboard boy brown. In this case, skateboard can be for the boy or for the girl. So the student have to do a connection. So we are expecting new ideas. At first, students have to explain to others. Then they have to show and compare. And then they have to show, explain to others, and give interpretation. So the book provides to the teacher ideas to give the opportunity of the student to get ideas to provide effective prompts. For instance, at the left side, we have the instruction, paint start light blue. How to understand start? We have two kinds of start. If we see the sky, we see a big point, bright point that is a star. And our flag present star 2 with 5 points. So different representation. So when we provide prompt, we have to be careful for an understanding it according to the representation. At the other side, we see the activity 1.A related to the dog houses. So here, the dogs are inside of the house. So the question related to where we can see more dogs depend if dogs are inside or no. Depend of the conditions. Depend of the situation too. So we have various representations, setting the step and setting condition and contextual meaning.
Okay. Coloring activities are a must for children. Reflection can be added to illuminate coloring activities. As teachers imagine the objective of the task, they can lead their students to achieve the goal. These coloring activities were produced to develop computational thinking. The tasks in their books improves the understanding and confidence in solving math problems. The Git book provides insight for teaching. Well done.
Yes, very good guidebook. Goodbye. Thank you.
So far, we have been discussing on the topic on computational thinking without computer. In the next section, computational thinking with computer will be the theme. Dr. Wayudi from Simeo Simolek and Dr. Warapon Prichapon from Simeo Rexham will give a presentation.
Good evening, our graduate MC, moderator, sorry. Okay, yes, indeed, it is like a transition from unplugged to plugged computer thinking. So, please allow me to share our screen. Okay. Can you see our screen, right?
Yes, we got you.
Thank you very much. As mentioned by Dr. Ravans and Wahyudi from Simulate and our co-presenters, my long good friends, Dr. Warapon of Simeo Rexham. Okay. So, for talking about visual programming here, in our chapters, we use Scratch, like, three open sources for visual programming. So, for Scratch itself, it has 5 components. Block represents programming commands such as movements, loop, and conditional and events. Okay, this is the blocks. This is the block. Also, second component is scripting. Users can snap these blocks together like Lego pieces to create sequence of actions. For example, to make a character move, you might snap together move 10 steps of 10 steps, block followed by a turn 9 security blocks, and so on. And next is script and backdrop.
The what you call the sponge, the snow, right? The volume structure.
Hello? Are you okay with me?
Yes, please continue.
Okay, thank you. Okay.
Thank you.
Right, it's like characters or objects, and backdrop is like backgrounds. So user can customize element by drawing their own or importing image and sound and so on. And event and triggers, this represents like, by keyboard inputs, mouse click, or timers. So we as users can define what happens when these events occurs by stacking block together. Last but not least, sharing and collaborations. Skill project can be shared online, allowing users to explore, remix, even learn from each others. So this is basically the environments of Scratch we use for our visual programming. Next, so from simple to more complex. For example, let's try to guess the meaning of script structures by using the given. So we ask our students to guess. So before, we ask students to guess and discuss, and then ask them to check and confirm. And finally, we can ask to check the parameter and comment, and let's see what happens in the Scratch program. For the task 2, we can ask if you add a repeat comments, what will happen for this? Okay, this is the background is here. Yeah. For number C. So look at the pictures for 2 seconds. How many dogs inside the house? So for the background is 1, C. So if the answer 1, great, you are cool. This is the correct answer. However, if the incorrect answers, then we say, sorry, let's try again, and so on. Right? So this is like the visual programming block of the Scratch for this background. For the more opens, okay, for this backdrop, what happens? How to look for times we change the text and backdrop, and what is the questions? This is the question for backdrop C. How about backdrop A, B, and D? So we have we give our opportunity to our students to explore, to create what kind of programs they need to stack together to have look for times for backdrops and so on. So this is like we will move to the next slide, a bit more explorations and a bit more complex. And for this month, I would like to invite our co-presenters, Dr. Barabon. Are you ready, Dr. Barabon?
Thank you, Dr. Wayudi. So
Okay.
I would like to explain what's going on for the computational thinking. That's at the beginning, we use the unplugged activity. We use this one for the unplugged activity. The student going to decide, take step from the neighboring cell, from the number 2 at the top. And also after that, the idea is from number 2 from the top and from the number 2 from the bottom. What are we going to meet the highest number? So from this idea in unplugged activity, we are going to translate the idea to be the Scratch programming. Now we are going to use the Scratch programming for comparing 2 numbers. Okay, this one is from the student learn from the previous activity. The previous activity we talking about the command that they are going to use the condition command, if, then, and else command to find out the larger number between 2 numbers. From the larger number, and then the student learn from this pattern. From this pattern, they are able to find the 3 numbers comparison. The student learn about the 3 number, and before they are going to think about the script for 3 number, they have to discuss what the script is about and what they can apply from the script from 2 numbers. Next, they have the idea that they learn from the previous activity, previous task. So this the idea they have to think if they have 3 numbers comparing. And this one is if the teacher lead them further is possible or not if they are going to compare phone numbers and so on. Then the question from this activity, the next question, Dr. Wayudi. Okay, the next question is, if they learn comparing for 2 numbers, 3 numbers, and possible they can write the script to compare more than 3 numbers. If this one, the student learn by themselves and try by themselves, they can see how to do the composition of the question. After that, they can see the pattern and find out the abstraction of the idea. And if they can see from the first activity, they can see the algorithm, the step of putting the block. Because of when you use the block, the step of adding the block is very important. So that from this activity, the student able to apply the computational thinking through Scratch programming. Thank you for this explanation for this slide. I would like to hand over to Dr. Wayudi to wrap up.
Thank you so much. Okay. So Dr. Barawan, since this all about our transition from unplugged to plugging. So this is like once I think that once our students familiars and also confidence, using block programming like in Sharp, it's a good foundation for them to move to the text-based programming like Python and JavaScript and others. With this, I would like to end our presentation. I hope this will take the time, 7 minutes. Thank you so much. Thank you, Dr. Lawrence.
Thank you, Dr. Wayudi and Dr. Warapan.
Thank you very much. So here, I would like to invite Dr. Masami Isoda live. So please, Dr. Masami Isoda.
Thank you very much for all of the speakers. I would like to confirm the textbook, okay? The guidebook. The guidebook is developed by Senior STEM Ed. And Dr. Warapan today just introduced the speakers. She appeared. And the textbook, guidebook, is edited by Dr. Crichasai and me and Dr. Roberto. And today, it's Shara-san, could you share the textbook download page?
Sure. Let me share you the slide I showed you in the beginning.
Okay. On the textbook, we use the chapter 1 examples and chapter 4's examples today. Okay. And there is a number table, and going the larger numbers from it begins from the 2. Dr. Warapan example. And that example also Dr. Roberto mentioned. Okay. Okay. You can download the textbook from this page. Okay. And if you download the textbook, the guidebook for unplugged computational thinking, okay. Today we use chapter 1 and chapter 4. Okay. And on the example of the Scratch programming, Dr. Warapan mentioned the number tables. It begins from 0 and going up to find the upper numbers. And Dr. Roberto mentioned several years ago when I met him at the beginning, okay, he wrote the program the game for the emergency evacuation in the case of fire. Okay, there's a number table. Behind of the map, number table is hidden. Okay, and in the case of fire going up, climbing up the mountain. Okay, and how shall we evacuate, and how the fire growing up. Okay, on behind of the map, there is such a number table existing. Okay, and the numbers show the height. Okay, so on the programming activities for the game and the emergency evacuation, actually there are flood and many problematic. And we have use the height and the water coming, the flood, and how it's come. For programming such a situation, we use such a number table behind. Okay, and such algorithm exists. Okay, so we can apply various situation, such ideas. And such things, on the background, there are such a computational thinking ideas. Okay, and such activities are embedded in the textbook. And the textbook is published from CMAIL STEM Ed. And with collaboration of CMAIL Creative in Mathematics, CMAIL Simulec, and CMAIL Lexam, and Gonken University, and University of Tsukuba. Okay? So please download the textbook and see the pages of chapter 1 and chapter 4. You can find the same examples, and you can understand more deeply. And at the same time, in the appendix, there are pages which explain mathematical thinking, computational thinking, mathematical thinking, and STEM thinking. Okay? Please read it. Thank you very much.
Thank you very much, Dr. Isoda, for the introduction of the textbook. So please, we hope you can successfully download from the QR codes. So, assignment time. So today's content is finished. So I would like to move on to the announcement of the assignment for next week. Let me share you the video.
Now we would like to inform you about the textbooks for this course. You can download the textbooks for this course from the following QR codes. Please click the title of the book and download the textbook. You will need to use the textbook for the assignment for this lesson as well. Thank you very much for learning in lesson 2. Here is the QR code for the assignment for this lesson. Please submit your assignment by 14th Sunday, 7 o'clock GMT 9. Once you submit, you will receive the link for lesson 3 by next Tuesday. This is the optional Google form for those who have questions to the lecturer for course number 1, lesson 2. For this form, please fill in the Google form with your question, and the deadline is 12th Friday. Thank you very much for attending today's course. See you back in course 1, lesson 3 on next Wednesday. See you.
Thank you very much, everyone, for joining. We'll see you next week. Bye.